Okay, now we're ready to discuss chapter 4, which is about max and min values. And so you've heard these terms earlier in your math career when you were in college algebra and pre-calculus, but now we're looking at it from the point of view of calculus. So we want to make sure we define these correctly. And so the first thing we're going to talk about is something called an absolute max. So on your worksheet that I've given you, it says f of c is an absolute max of the function f if, and so I have a blank there, and this is what you need to put in the blank. If f of c is greater than or equal to f of x for all values, of x, for all values of x in the domain. So if this y value is greater than or equal to every other y value on that function, then that is called the absolute maximum of the function. Similarly, an absolute minimum is if you have some value f of c that is less than or equal to every other y value of the function for all. This is for all values of x. This is the same for all values of x on the domain, okay? So that is what an absolute max is. It means it's absolutely the highest point that you will ever achieve. Absolute min is absolutely the lowest point that you will ever achieve. Not all functions have an absolute max or min. For instance, here is a parabola. Let's just get a picture in our mind. This function has an absolute min right here, but it does not have an absolute max because it goes on forever. However, if you're on a closed interval, that changes things, and so we'll be looking at that. If you had a parabola, this is a very simple graph. This has an absolute max, a high point, but this has no absolutely low point, no absolute min right there. So that is just a quick illustration of a possible absolute max or min. Local max or min is often called a relative max or min. So they might use the word local, or they might use the word relative, and what it means is a high point, a maximum is a high point in the general area, locally, in the local area, or the relatively speaking, a high point. So it might be a hill that you come across, or a local min might be a local low point that you come across. So just as a graph, if you have some, let's say we have some function like here, maybe we'll make it go up like this. So it goes on forever, let's just say. All right, we would say in this case, this had no absolute min because see how low it goes? It has no absolute max. Let's make that look like it's going up forever. Okay, no absolute max. However, this one would have a relative max because in the general area of x, there's a high point, and in the general area of x, there's a low point. So this one has a relative or a local max, a relative or a local min. So how we would illustrate this or write in our blanks right there, it says f of c is a local max if f of c is greater than or equal to every other y value f of x for x. Here's the difference, for x near c, for the x values that are near c. Similarly, a local min would be if f of c is less than or equal to every other f of x value for x's that are near c. Not for every x value, but for ones that are near c. So that's how we define those. Let's go to example 1, which says, use the graph to state the absolute local max and min values of the function. I'm sorry, to state the absolute and local max and mins of the function. So I've copied this down on my whiteboard to be similar to what you guys would see. And so this is what we have, the graph. And so first let's talk about absolute max and absolute min. So let me see if I've drawn this. I have not drawn this. Let me draw it a little bit more to like yours is. We have this point here, and we have something that does more like that. Okay. So we would look at this and say, hey, is there an absolutely, and this goes lower. Let me make this lower so it looks a little bit better. Okay, this doesn't go quite as high. All right, this looks a little more like what you guys have on your worksheet. Okay, so for number 1, it says, what is the absolute max and absolute min. Let's tackle those first. What is the highest place that we see on our graph? And right here is the highest place that we see on our graph. But that is an open circle, and that is not defined. And we can't really talk about what this point is right there. We can't say what that highest point. It's the point as close as we can get to 5 without it being 5, which nobody can really say that. 4.999999. We can't capture that. And so this one has no absolute max. This is what we'd say, no absolute max. Okay. Let's see. Does it have an absolute min? Is there an absolutely lowest point that's lower than every other point? And it does right here, and it's better to see on your worksheet, but right here, this little point down here goes all the way down to 1. Maybe I didn't make it low enough on mine. This one goes all the way down to 1, and that is lower than every other point on the graph. So it does have an absolute min of 1. That's the y value that occurs at, 2, 3, 4, at 4. So you could also say of y equals to 1 that occurs at x equals to 4. Okay, that's the absolute. Also, by the way, absolute maxes, absolute mins are also known as the extreme values, and that will come into play when we hear a theorem that's coming up. All right, now let's talk about, are there any local mins or local maxes in the general area? All right, let's look at this. Let's start with the local maxes. Are there any local maxes? All right, near x. Okay, I see one right here. There is a local max right there. That's kind of a high point, higher than any of the other ones around. And here's another one. There's another high point. So I see 2 of those. I see that has a local max of 4 at, where does this one occur? At 3, at about x equals to 3. At 3. So remember, you could always say of y equals to 4 at x equals to 3. Either one of these is appropriate. There's another local max high point right here. And that one is a local max of 3 at y equals to 6. At 6. At x equals to 6. Of y equals to 3. So I'm just showing you what I'm saying here. The local max of 3 is interpreted to be of y equals to 3 at 6, at x is 6. So that's the local max and local mins for that one. Let's see, was there, the mins, I haven't tackled the mins yet. Let's look at those. Minimum values, is there any low points? Okay, do we see any? Here's one, definitely. Here's a low point. It's that little dip. Also, this is a local min. That is a little bit strange, but in the general area, that's the lowest point that we see. So that one counts as a local min. There are local mins. There are 2. There's a local min at, of 2 at x is 2. Okay. And there's another local min of 1 at 4. Okay, so that is how we would think about that graph. So there's some pictures of that. Second thing we have to do, and some of this was on test 1, you can expect some more of this on test 2 where you have to come up with your own graph. It really tells me you know how to interpret things. So be expecting that. Sketch the graph of a continuous function on this interval from 1 to 5. So we know that between x is 1 and x is 5, including 1 and 5, this graph is continuous. There are no gaps in it. So we're going to draw a picture like that with these conditions. There's going to be an absolute max. The highest point it will achieve will happen when x is 4. And an absolute min, the lowest point it will achieve is at x is 5. There will be a local max at 2 and a local min at 3. These are the conditions. Our graphs will not have to be exactly the same, but we will have to meet these conditions on all of them. So first, I'm going to draw myself a little grid, and mark this is 1 and this is 5. Now what happens outside of 1 and 5? It could be discontinuous. It doesn't even have to continue, but we know it's defined between 1 and 5 and it's going to be continuous, whatever we may decide to have happen. The interesting places here are at 4 and at 5. So at 5, at x is 5, I know the absolute min occurs, the lowest point that's going to achieve is going to be there. So what I'm going to do is I'm just going to go ahead and say, okay, this is going to be the lowest point that my graph is going to achieve. I chose to put it below the x-axis. You don't have to do that, but that's just what I decided to do. And the absolute max is going to occur. Let's see, let me put this on here. This will be 2, 3, and 4. This is 2, 3, and 4. Let me make my graph in a different color. I'm choosing for this to be my lowest point. Now, if it's not working out, I might change that, but then the absolute max occurs at x is 4, so it's going to be the highest point is up here. So I don't know, maybe I'll put this up here, 5. Now if I decide that these are two, if I can't make a good drawing, I might have to change that. But it occurs at x is 4. Okay, what has to happen on the in-between? There's a local max at 2, so it's going to have a high point, but not the highest point at x is 2. So it's going to have some kind of, up like that at 2. And there's a local min at 3. Now, it doesn't have to mean it's super low. It just means to have like a low point. So what I might choose to do, I'll have this guy go down. Okay, so it's going to have some kind of up and down. This is how I'm going to have to do it. Okay, so I'm going to come in here. I don't know where to come in here. Maybe I'll have it coming up from here, because I don't want it below my lowest point that I've set. Okay, so I'll just have them coming in here, and I'm going to have it go up, down, and spike up here, and then maybe I'll just have it spike down there. Let's see. I think that's okay. Did I meet the conditions between 1 and between 5? It is continuous. All right, that's fine. It has an absolute max at 4, so it does. I could name my y, but I don't have to even. This is the highest point it achieves. It has the absolute min at 5, okay. It has a local max at 2, okay, a little high point there, and a local min at 3. Okay, that works. That's one way you could draw this graph, and that's how I chose to draw mine. Okay, so let's go on. Then we're going to introduce, here's the extreme value theorem. The extreme value theorem means the absolute max and mins. And so what this says is, if f is continuous on a closed interval, so this is a big deal. Here's the conditions that have to happen. F has to be continuous, and it has to be on a closed interval similar to this, between 1 and 5. If you have those conditions, then you can say that f will attain its absolute max and an absolute min on that interval. You can always find an absolutely high point and an absolutely low point on that interval. That's what it says. So let's just play around. I'm going to draw some different graphs for us to look at, so we can say, how would this work? What they're saying is it has to be, the conditions are, it has to be continuous, and it has to be on some closed interval between A and B. Yeah, okay, so we'll just draw some different pictures and see what that looks like. So right here, between A and B, here is one grid we could make. It didn't say positive or negative, it doesn't matter. Just draw yourself some little grids. So let's see. Here is A and here is B. A and B. Here is A and here is B. A and B. Here is A and here is B. Here is A and here is B. The conditions are that it has to be continuous and it has to be on a closed interval. So here's my closed interval. Somehow I'm going to go from A to B. What if I say, okay, here's A and here's B. There's one. All right. Here is A and here is B. Okay, that's fine. Here is A, and let's see, what if I want to do, here is A, and here is B, okay? Here is A, and here is B. These are just four of an infinite amount of graphs you could draw. But this is just to illustrate. This is by no means a proof, but let's just say we've met the conditions. Can we find an absolute max and an absolute min on these? All right, let's just see. Where would, I'm doing maxes in purple. Let me try to stick with that convention, and mins in blue. What's the lowest point that I see here? Here's a low point. This one looks a little bit lower. Oh, no. Here's the lowest point right here. This is the lowest point. Here's my absolute min right here, and it occurred at B. All right. Where's the absolutely highest point that I see? Well, it looks like there might be two. These look like these are at the same place. I found two absolute maxes right there. So we found the absolutely high point. It occurred more than once. That is acceptable. Okay, right here. Where's the lowest point that we see on this graph? Well, the lowest point is here again at B. All right, B was where it happened at B. That doesn't happen every time. This is the low. And where is the high? The high was A. All right, max. And this is absolute min. Okay, this was the max. This was the min. Okay, where is the lowest point? Oh, here. Here, I think, is the lowest point. Okay, there. That was at A. Where's the highest point? Oh, look, this looks like the highest point right here. Am I getting these mixed up? It looks like I am. Okay, anyway, that's okay. This is the highest point up here. It occurred right here. All right, where's the highest point here? Oh, here. Oh, no, that one's higher. Here. All right, where's the lowest point? Looks like those are both the lowest point. Okay. Okay, the conditions of the extreme value theorem said f has got to be continuous on a closed interval, so all of these were. And then it said if that's true, then you will always have an absolute max and an absolute min. And we definitely found an absolute max and an absolute min. Let's take note of a few things. Here's the first thing. Functions that are on a closed interval always attain their extreme values. You can always find a max and you can always find a min. However, this is other things. An extreme value can occur more than once. That happened in these illustrations. Right here, I had two places where it achieved its absolute max. Right here, I had two places that it achieved its absolute min. That can happen. That's acceptable. Here's another thing to take note of. An absolute max or an absolute min can occur at an end point of the interval. It happened here. This one occurred at B. Oh, the extreme values occurred at A and B here. Here it occurred at A. Here it occurred at A and B. It doesn't have to, but it did. The other thing that we see is that extreme values can occur not at A and B, somewhere in between. Here's in between, here's in between, here's in between. So they can occur at endpoints or they can occur in between. Now, we're ready for the next little part where we talk about critical values. So a critical value is simply, so I'm on the second part of your worksheet. Let me just pause, so maybe you do this in part two. So we'll do part two of your worksheet now.